I'm Anil Kumar, and in this video we'll prove the basic trigonometric identities. We need to prove each of the following. First one is cos of minus x equals to cos x. Then we have sine of minus x equals to minus sine x. And you can also add c, which could be tan of minus x is equal to what, right? So it is actually minus of tan x. So you could add that. Now let us see how to prove these identities. I can show it in more than one way to prove these identities. The first method is, let us sketch what is cos of minus x and what is cos of x. Let us say this is the angle x, right? So in that case, minus x will be clockwise, right? So the same angle minus x. So these two equal angles. That is minus x. Now when we say cos of minus x and cos of x, then we are actually comparing two positions of the same point in different quadrants, right? So you can see if I take 2 points, let us say P and its image P dash reflected on x, for example, in that case coordinates of P will be xy and the coordinates of P dash will be x minus y, since it is going downwards. Do you see that? So those are the coordinates. And OP is R, let us say, right, which is where R is equals to square root of x square plus y square, which is always positive. Now what is cos of minus x? Cos of minus x is we are working in this triangle, will be x over r, right? So is x over r, and cos of x is also x over r, right? So they are both equal. So you can say that cos of minus x equals to cos of x, correct? So both are equal. If you do the same thing for sine, then what do you get? So I'm not sketching it again, but let us do the same thing for sine. So in the case of sine, sine of minus x will be, you're working on this particular triangle, so y value is minus y, right? So sine of minus x is minus y over r, whereas sine of plus x is this y over r. And from here, you can place sine of x, sine of minus x, which is minus y over r, as equals to minus of y over r. Instead of y over r, let us write sine x, correct? So that is what we get. So sine of minus x is minus sine x. That is one way of doing it. You have also studied compound angle formulas, right? So we can use compound angle formulas to prove this also. Consider sine of 0 minus x, for example, correct? Both in degrees, for example. Is it okay? In that case, if you expand it, what do you get? You get sine A cos B, which is x, right? Minus sine of x cos of 0. Is it okay? So this is what you get. Now sine of 0 is 0, right? Sine of 0 is 0. So 0 minus cos of 0 is 1. So we get minus sine x. Do you see that? So what we get here is that sine of minus x, this is sine of minus x, right? So we have sine of minus x equals to minus sine x. So what we get here is sine of minus x equals to minus sine x, correct? On the other hand, if you do the same thing for cosine, so let's begin by cos of minus x could be written as cos of 0 minus x. Is that okay? So let us expand this one. So what do you get? You get cos of 0 times cos of x plus sine of 0 times sine of x. Now cos of 0 is 1, so you're left with cos of x, and sine of 0 is 0, so you get 0 here. So what we get is that cos of minus x is equals to cos of x. So that could be, using compound angle formula, you could prove the same thing. I hope that helps to understand the concept. Thank you and all the best.